Welcome to Astrocast.tv, your source for news and information about astronomy and our solar system. Now, here are your hosts, NASA JPL Solar System Ambassadors, Greg Redfern and Dr. Lori Figge.
It's episode 10, and I'll be talking about dark energy and some recent sky spectaculars caused by falling space rocks.
The Space Shuttle Discovery is set for launch to the International Space Station and will be carrying the last segment of the station's backbone to include the station's final set of solar arrays. But first, some headlines.
Next Giant Leap, nextgiantleap.com, a small company that was the 15th to register for the Google Lunar X Prize, publicly announced its name and team members at a press conference December 17th at the NASA Ames Research Center. Next Giant Leap founder Michael Joyce said, "With the world-class team we have assembled, we are ready to take the next giant leap forward, required to win the Google X Prize and establish NGL as commercial lunar services company." The Google Lunar X Prize is a robotic race to the moon to win a remarkable $30 million prize purse, where teams from around the world are competing to land a privately funded robotic lander on the moon that is capable of completing several mission objectives.
In light of recent developments that threaten to lead to the breakup of the Wilkins ice shelf, ESA is making daily satellite images of the ice shelf available to the public via the Webcam from Space webpage in order to monitor the developments as they occur. The Wilkins ice shelf, a broad plate of floating ice off the coast of the Antarctic Peninsula, has undergone many changes in 2008. According to ESA, if the ice bridge were to open, it could put the entire ice shelf at risk of disintegrating.
NASA has issued a request for information seeking ideas from educational institutions, science museums, and other appropriate organizations about the community's ability to acquire and publicly display the Space Shuttle orbiters and Space Shuttle main engines after the conclusion of the Space Shuttle program. Sponsored by NASA's Office of Infrastructure, the RFI seeks input from appropriate officials and decision makers from museums, science centers, institutions, and other organizations dedicated to education or educational outreach. Organizations interested in responding to the RFI must provide their input to NASA by March 17, 2009.
The Inauguration Committee for President-elect Barack Obama officially extended an invitation Wednesday for NASA to be part of the 56th inaugural parade on January 20th. The crew of NASA's recent STS-126 Space Shuttle mission and other agency officials will join representatives from across the country and our armed forces in this historic parade down Pennsylvania Avenue in Washington, following swearing-in ceremonies on the steps of the Capitol.
Have you heard of the Bad Astronomer? Well, his name is Dr. Phil Plait, and he really is an astronomer. But what he talks about is bad astronomy or bad science in movies, TV, and debunking science myths. Which of the celestial scenarios spooks you the most?
Ooh, if you phrase it that way, if you say spooky, I would have to say it's the end of the universe itself. And this was something I had to really research carefully because we don't know a huge amount about this, and so some of it is still speculative. But we're talking about the universe being a few billion years old, and so you could kind of think, well, what's it going to be like in another 10 billion years, another 20 billion years? And we can sort of understand that. But then you start adding more zeros to that. What happens in a trillion years? What happens in an octillion years? You know, if I had 30 zeros to that, you know, will we even have matter? And it turns out matter itself can decay. Protons will fall apart, and matter as we know it won't exist. And eventually the universe will be sort of a thin, cold soup of energy and particles just floating around. And that to me was really spooky. That creeped me out. It's not the scariest scenario. I think the gigantic explosions sterilizing the planet, those kind of things are scarier, but the end of the universe itself is what kind of creeped me out.
You can see all my interview with Dr. Phil Plait, a.k.a. the Bad Astronomer, on the Astrocast.tv website sidebar. And Dr. Plait has a brand new book out called Death from the Skies, and it's real science about astronomical disasters.
Space Shuttle Discovery's mission to the International Space Station, designated STS-119, is now targeted for launch on February 12, 2009 at 7:30 p.m. Eastern Time from NASA's Kennedy Space Center in Florida. This is Discovery's 36th mission, and it will be 14 days long. The shuttle will be docked to the International Space Station for 10 of those days, while the crew delivers the S6 element of the integrated truss structure. This structure is the last segment of the station's backbone, and it includes the final set of solar arrays for the space station, providing it with enough power to accommodate a full crew of 6. The shuttle crew will perform 4 spacewalks while docked to the station. Lee Archambault will command the Discovery's mission. Tony Antonelli will serve as the pilot. 5 other mission specialists from the United States and Japan will join them. Wakata from the Japan Aerospace Exploration Agency will replace Sandra Magnus on the space station. She will return to Earth on Discovery. In addition to the important delivery to the space station, Discovery's payload includes several experiments, including the boundary layer transition test experiment. With this experiment, a thermal protection tile, like those covering the shuttle, will be installed slightly raised above the others to simulate a damaged tile. 13 temperature sensors will be installed in nearby thermal protection tiles to monitor the temperatures of the tiles during re-entry.
Dark energy. Even the name evokes mystery and hard to conceptualize visions of the inner workings of the universe. Simply stated, dark energy is the dominant repulsive force that is accelerating the expansion of our universe and hindering its development. Dark energy cannot be seen, but it can be detected by the effect it has on the matter in our universe. Major new findings were announced recently at a news conference held by NASA to explain observations made with the space-based Chandra X-ray Observatory of galaxy clusters. The multi-year observations clearly indicate that the growth of galaxy clusters, the largest structures known in the universe, have been stifled or made smaller than they should be due to the influence of dark energy. Using Chandra, astronomers observed hot gas located within dozens of galaxy clusters, some relatively close by and others halfway across the universe. The data show that the stretching of space caused by the influence of dark energy made it difficult for galaxy clusters to grow in size and mass, and when such growth did occur, it was aligned with dark energy. Dr. Alexei Viklilin of the Smithsonian Astrophysical Observatory says that putting all of this data together gives us the strongest evidence yet that dark energy is the cosmological constant, or in other words, that nothing weighs something. He also states that a lot more testing is needed, but so far, Einstein's theory of general relativity is looking good as ever. Albert Einstein had originally inserted a cosmological constant in his theory to counterbalance the expansion of the universe that his equations showed must be occurring. He later claimed that it was his greatest blunder. If these observations about dark energy being the cosmological constant are confirmed, the destiny of our universe is one in which it will continue to accelerate in its expansion. Tens of billions of years from now, we will not be able to observe the host of galaxies we can now. They will simply be too far away and invisible. Superclusters of galaxies will also disintegrate and be no more.
Now that winter is officially upon us in the Northern Hemisphere, let's take a look at the constellations of the winter hexagon over the next few episodes. The bright orange star Aldebaran of the winter hexagon marks the eye of Taurus the bull. You will notice a V of dimmer stars near Aldebaran, tracing the shape of the bull's head, and 2 other stars that mark the points of its horns. The stars in the V of the bull's face are actually members of a star cluster called the Hyades, all except Aldebaran. Another open star cluster is found in the constellation of Taurus, away from the head and horns of the bull. It's the brighter and more compact Pleiades, also called the Seven Sisters. The Pleiades is a younger cluster than the Hyades, young enough that its stars are still surrounded by gas and dust. Most people can see 6 stars naked eye, and many more in binoculars. With a telescope, you can see hundreds of stars, and on a dark and clear night, you might see some of the nebulosity around the stars.
For all of us here at Astrocast.tv, I'm Greg Redfern.
And I'm Lori Figge.
Tune in next time as we learn more about the wonders and mysteries of the universe in which we live and explore.